Hello, everyone. My name is Allison. I'm a poet, programmer, and game designer and assistant arts professor at ITP-IMA. I am here representing my co-authors, Jenny and Tim, to talk about the Nonsense Laboratory, which is a series of playful web-based tools for manipulating the way words sound and the way words are spelled. It consists of a set of interfaces for adjusting, poking at, and otherwise mangling the sounds of words in written text. The project makes use of Pencilate, a code library and machine learning model for phoneme to grapheme and grapheme to phoneme tasks in English, trained on the CMU pronouncing dictionary. Our goal was to make a fun and maybe useful toy for being expressive with spelling, make it feel like playing a musical instrument or modeling a play, and also to demystify machine learning and provide an intuitive, friendly interface to one particular machine learning model. So I'm going to talk a little bit about the history of the project in the context of my own creative practice as a poet, and then talk about the specifics of the Nonsense Laboratory itself. So the Nonsense Laboratory has its origins in a problem, which is that in the course of my poetic practice, I found myself appreciating sound poetry, nonsense poetry, glossolalia, works like Elsa von Freytag-Loringhoven's I Gassing Renjalaman, which I'm showing here on the screen. These are works that are composed mostly of made-up words. So in my own practice, I wanted to be able to use the computer both to analyze made-up words like this and also make up new words that have particular phonetic characteristics. There are, of course, a bunch of existing grapheme to phoneme models out there that can cope with out-of-vocabulary words. There aren't as many phoneme to grapheme models for some reason, but they do exist. But none of them had exactly the kind of flexibility I was looking for. So I made my own called Pencilate. Pencilate is a pair of models, one for grapheme to phoneme translation and the other for phoneme to grapheme translation, trained specifically with poetic uses in mind. The name Pencilate, by the way, was generated by the model itself using part of the model that I listed in a second. I also made a little Python library to go with this that makes it easy for people to write programs that make use of the model. So there are a couple of details of the model that I need to get into so that we can understand the Nonsense Laboratory a little bit better. But first of all, Pencilate is trained on the CMU Pronouncing Dictionary, which is a freely available database of English words and their pronunciations. There on the left are the words, and on the right are the pronunciations in a phonetic transcription system called Alphabet. Importantly, Pencilate represents phonemes not as atomic units, but instead as bundles of phonetic features. So by phonetic features, what I mean by that is what phonemes are made up of. In the case of Pencilate, are used articulatory theory of phonetics, where the articulatory features correspond to the motions that the mouth is making when a phoneme is being articulated. This representation gives the model the information it needs to know that some pairs of phonemes are more similar to each other than others. For example, ba and pa, and I'm realizing that you can't see my mouth. So I'm doing as in and as in purple. Those are more similar to each other than say ha and ba, ha as in pack. On account of the fact that both e and p are pronounced with the lips. Having this information helps the model cope better with missing or ambiguous information, and that's important considering the things that I'm trying to get the model to do. And you might recognize this slide from my EPSAG 2017 presentation, which was also sort of part of the origin of this research. So this is the structure of the model, and from the fact that I'm using recurrent neural networks instead of transformers, you can probably pin down to like the exact date, exactly 2017 when I started working on this. So you take the orthography or the spelling of the word, it goes through some recurrent neural networks, and then it predicts the phoneme features as a two-dimensional array of features and type steps. And then another model takes those phoneme features and then translates it back into the predicted spelling. Now, it seems like a weird way to do the model because if I already have the spelling, I don't need to predict the spelling. But what this allows me to do is use various parts of the model for poetic ends. So for example, I can use different states of the RNN as feature vectors that represent the word sounds, and I can manipulate those feature vectors and inject them back into the model. I can also, at the point of decoding, when I'm converting the letters to sounds or the sounds into letters, I can or diminish probabilities in order to create interesting phonetic or orthographic effects, your classic logit warping. So here's some examples of things that the model can do. The first, like most basic thing, is denoising sequences of random characters. So on the left here are just letters that are selected from a uniform distribution of English letters and other symbols that are in the sequence announcing dictionary. On the right is the input of the model given that inputs, essentially creating plausible looking English words from these random inputs. Another thing that you can do is take the hidden state of the RNN and then add some noise to it. In this case, I'm just adding a little bit of random normal noise to that vector and injecting them back into the model and having it spell from that. And what it does is it produces variations on words, like phonetically plausible variations of words. So I'm showing some variations of the word abracadabra right here. Another thing you do with the model is take that hidden state, the feature vector for a word, and then average two of them together, divide by 2, and then that back into the model. And what it does is it produces the phonetic and orthographic average of two words. So between paper and plastic, the model generates deceit. Between kitten and puppy, the model generates puppy. Between birthday and anniversary, the model produces Arthur Day. And between artificial and intelligence, we have intellificial. I used this in my own practice to make a book of poems called Compasses. This was published in 2019 in Andreas Volkoff's Sync series. The way that a compass poem works is that I came up with a list of quartets of things that are sort of mutually exclusive, and then the model generates words that are in between those words on the point compass, which is where the name of the poem series comes from. And then the middle is the average of all of those words together. So I'm going to show a few more examples of these. This is noon through 3, this 6, Nick 9, noon 9. And then this one is my favorite. Google, Allison, Amazon, Eastbound, Facebook, Aspel, Apple, Ogle, Aspel. So I was having a lot of fun with this model, and I wanted to make it easier for other people to have fun with the model. So I had the Python library that people can download and a bunch of example Jupyter notebooks, but that's still a pretty narrow audience. I wanted to make it even more accessible. So I pitched the Nonsense Laboratory to several of the various groups at Google who are tasked with making machine learning accessible to lay people. The project involved porting TensorFlow.js, so it would run in the web browser, and then creating playful user interfaces for various affordances of the model. So this is the original hand-drawn mock-up drawing that I sent with my proposals, which I guess were cute enough to give me some money from Artists Machine Intelligence and Google Arts and Culture both provided money for this project. So I know how to do programming and how to guide the overall direction of the project as the artist, but I also needed help with visual design and UX design and just emotional support. So I brought in 2 collaborators, Tim Szetela and Jenny Goldstick, who are also co-authors of this paper, and I'm delivering the paper here on their behalf. So there are several components of the Nonsense Laboratory, and I'm going to go through them one by one. So the first is the mixer. The mixer does essentially the same operation as I demonstrated earlier for the compass poems. The user types in 2 or more words, the code finds the mean of the hidden states for those words, and then injects that vector back into the model, and then produces the output there at the bottom. We get breakfast plus lunch plus dinner, these drinks. The mouthfeel tuner rewrites a text so that the words feel different in your mouth. There's a text area for the user input, and then some sliders with impressionistic or onomatopoeic labels. Adjusting those sliders transforms and respells the text so that it contains more of the sounds indicated in the label. For example, the phrase crocodile improves meaning tail with the slider turned all the way up becomes how doofed the lipple propopile improve if finding tail. The phrase interactive digital entertainment with the slider turned up becomes enteroctive, vacatile, and autonomous. The underlying code performs the equivalent of logit warping in the output layer of the grapheme dephoneme model, emphasizing or attenuating the probabilities associated with each phonetic feature before decoding. So for example, in the imperfect example, the phonetic features are those that are associated with the lips. It's boosting those and attenuating others. The respeller is the graphic part of the mouthfeel tuner. It rewrites a text trying to retain its sound while omitting certain letters. The interface presents a text area that you can for user input alongside a list of letters. That tapping or activating those letters toggles the active state of the letter. When the apply button is activated, the text in the text area is rewritten such that any of the letters that are set as inactive are not used, but the sound of the word is still as close as possible to the original words. So essentially what's happening is the output layer of the phoneme graphing model is modified at each time step such that the probability of any deactivated letter in the interface is set to 0. The model has to proceed as best it can to spell the word as though the graphemes in question did not exist. There's also the sequencer, which spells a word from virtual mouth movements that the users put in sequence similar to the interface of a drum machine. There's a grid here where the columns are time steps and the rows are individual phonetic features. And an active square turns on that feature at that time step, and inactive square turns off that feature at that time step. And then you click on play, and then it spells that word in the bottom area here. This interface also has like an accordion thing to reveal like the more advanced esoteric phonetic features. We just judged that made it a little bit less intimidating for users when first approaching the interface. So essentially what you're doing here is constructing the input to the model. The way that the model is trained is that there's a two-dimensional array of time steps which are individual phonemes, and then an array that is 0 to 1 according to whether that phonetic feature is present. Finally, there's the Explorer, which presents a Google Maps-like interface that encourages you to zoom and pan around an infinite field of nonsense words in which neighboring words have similar phonetics. Some of the words on the map are real, and you search for those in the search field, and then the surrounding words are phonetically similar to it. Those are generated by the model. So I want to talk about the visual design and user experience of the Nonsense Laboratory. Our guiding principle of the visual design was playful but not childish. We took inspiration from mid-20th century analog control panels and analog synthesizers, and tried to temper that high-tech feeling with bright colors, bold lines, generous spacing, and subtle motion design that responds to user interaction. And I think we ended up with a visual design that doesn't resemble a child's toy or a highly technical tool, but still invites play, but doesn't foreclose on more practical uses. The Nonsense Laboratory, as I mentioned, was developed for Google Arts and Culture, and if you go to their website, they say their audience is anyone, anywhere, which is a pretty wide audience for a machine learning project, or an art project, or a poetry project. We entered the design process believing that the kind of language play that facilitates is inherently fun and intuitive, even to an audience of this scope. But both nonsense words and machine learning are pretty esoteric subjects, so we knew that we had to find strategies for welcoming folks in. So some of our strategies, first of all the interfaces in the laboratory are pre-populated with example input, or have preset examples that the user can select. Each interface shares a common design language that helps to communicate to users how and where they can interact. And each interface also has a help photo dialog that pops up that describes in plain language the function of the interface in more detail and gives the user some things to try. Some other specific design changes that we made over the course of making the tool in response to user feedback. The original proposal was a single screen application. This is the original visual mock-up here on the left. It was a single screen application that would show all of the interfaces simultaneously. We rejected this idea pretty early on because it wouldn't be viable on mobile devices, but have a smaller useful screen area, and it would just require too much density in the interface and wouldn't give us the space we needed to put the necessary messaging and the interface elements that we needed. So we decided to split them up into individual pages with a menu at the beginning, and that's what you've been seeing in the throughout the presentation. The original design also included an interface called the phonetic editor, which I'm showing the mock-up of that here on the left, which had the combined functionalities of what became the respeller and the mouthfeel tuner. Both the respeller and the mouthfeel tuner make use of the same underlying function in the configured model software, which is why it was originally like that. But during the course of user testing, we found that it was overwhelming to users to have all of that on the screen once, and that made the interface less approachable. So our solution was to, even though under the hood we're actually running the same function in the library, to break these out into two separate interfaces. And that just allowed the interface to have a bit more room to breathe. There's more technical details and more design stories in the paper, but I am running out of time, so I want to thank Holly Grimm and Hannah Andrews. Holly Grimm was one of the programmers at the beginning of the project who did the first work on porting Pencil to JavaScript, and Hannah Andrews was our producer at Google Arts and Culture, who was very generous with time. So yeah, that's all I've got. That is the website of the Laboratory, and that's my website.